Hello everyone, and welcome to Biopedia. When Alfred Russell Wallace is thought of today, it is probably as an accompaniment to Charles Darwin and the theory of natural selection. However, Wallace was a preeminent scientist in his own right. Today, we're going to be examining his impact on zoogeography, which is named for him, the Wallace Line. In 1876, Wallace published a book called The Geographic Distribution of Animals. In it, he argues for the existence of different biogeographic regions, based on the worldwide locations of various land animals. These regions would have had faunas which were recognisably different from each other. There were 6 of these regions: the Nearctic, the Neotropical, the Ethiopian, the Oriental, the Palearctic, and the Australasian regions. These overlap reasonably well with the Earth's tectonic plates. Specifically, if we were to only consider large plates, there would be broad agreement with the North American, South American, African, Eurasian, and Australian Indian plates respectively, with both the Oriental and Palearctic faunas largely sitting on the Eurasian plate. These distinctions between faunas become relevant in the context of the Wallace Line. In 1852, Wallace travelled to the Malay archipelago. While there, he noticed that the fauna of the archipelago was rather puzzling. Specifically, he noticed that the animals living in New Guinea more closely resembled the fauna of the African continent, rather than that of the Philippines in the substantially closer Oriental biota. Given the distances involved, this would at first glance appear to be counterintuitive. So, why does this unusual similarity relationship exist? Well, it's because these lineages evolved in very different areas, and only ended up next to each other geologically recently. Southeast Asia used to be part of the continent of Laurasia, while its counterpart was part of Gondwana. These two continents are basically the two halves of the former supercontinent Pangaea, which separated from each other during the Jurassic period. Thus, the recognisable patterns observed by Wallace in the 19th century stems from the many millions of years of separation between the two groups and the inability to breed together that resulted. As a quick aside, this meeting of two disparate biotas is reminiscent of the Great American Interchange following the unification of North and South America, which is a topic we will return to in a few weeks' time. Now, the difference between the two faunas is noticeable. Many species of fish, mammals, and birds which are abundant in one region are virtually absent in other regions. This division between different areas is in fact so prominent that a border has accordingly been proposed to formally separate the two faunas, hence the Wallace Line. This name was not given by Alfred Russell Wallace himself, but instead by Thomas Henry Huxley after he'd read some of Wallace's writing on the subject. Animals on one side of the Wallace Line derived from Asian biota, while the other was descended from the Australasian biota. The Wallace Line is not a precise demarcation, and some are of the opinion that it doesn't exist at all, but as with the biogeographic regions mentioned above, it approximately lines up with the continental shelf boundary of southeastern Asia. The islands near the line, specifically to the east of it, are known in biogeographic circles as Wallacea in his honour. The fauna of these islands are apparently noticeably different from surrounding faunas. Birds on the islands, although they are capable of travelling to both nearby continents, usually remain where they are. Because of this, they have diverged a lot due to reproductive isolation. It is, apparently, uncertain why nearby organisms don't cross the Wallace Line. Importantly for our own human story, Denisovans are known to have made it over the Wallace Line. In brief, the Denisovans were a separate group of humans which are known to have mated with Homo sapiens. They were initially discovered thanks to genetic evidence teased out of a single finger bone found in a cave in the Altai Mountains of Russia. In the context of the Denisovans, the problem the Wallace Line presents is in the form of a strong marine current down eastern Borneo which would preclude travel across it. Denisovans are known to have mated with our own species in Indonesia. However, this wasn't the case in Asia, even though their fossils are present on the continent. In fact, the only DNA evidence of interspecies mating is east of the Wallace Line. This distribution supposedly only makes sense if Denisovans manage to make it across the line. After making it over, they subsequently bred with Homo sapiens travelling towards New Guinea and Australia. So, that's it for this episode. Thank you all for listening. For any questions or comments, or topic suggestions for future episodes, you can contact us at the show's email address. Until next time, have a great week, everyone.